Hello students, welcome in 12 Computer Science. Already we have started chapter 1 operating system in paper 1. We have completed session 4. Now in this session I am going to explain concept related to process management. Now student, you know already what is the function of process management. Process management is one of the services of operating system. In process management means delay process, resume process, suspend process, create a new child, terminate process, etc. So this is the function of process management. While moving to the process management concept, you should first know that what is process. What is process? A process is a program under execution which competes for the CPU time and other resources. This is the definition of process. These all definitions in this session asked in board exam for 1 marks. Okay student? So a process is a program under execution which competes for the CPU time and other resources. Means those program which is ready for execution but that program wants CPU time and other resources. Other resources means suppose you want to take printout, okay, some print for some applications, then you need printer. This is the resources, means other resources. Okay student, a program loaded into main memory for execution becomes a process. Means those program which is loaded into memory, that is execution, that becomes a process. That becomes a process. Means which those program which is loaded into main memory, that is execution. When program loaded into memory means that program is execution process and that becomes a process. Understood student? It is called as process. This question asks for 1 marks in board exam. Now, next topic is multiprogramming. Multiprogramming. Multi means more than one. Multi means more than one. In multiprogramming, CPU can execute 2 or more processes simultaneously. Means more than one process can run simultaneously. CPU works continuously. CPU works continuously means is in utilization of CPU by always having something for CPU to execute. Means always there are some program to be executed. That is increase the CPU execution and multiple programs can run. This is known as multiprogramming. Now see the diagram. See in this diagram, run process 1, then run process 2, again process 1, run process 2, run process 1, run process 2. Okay, means here we having process 1, here we having process 2. Now again process 1, then again process 2, again process 1, again process 2. Okay, this is the diagram of multiprogramming. In this multiprogramming diagram, more than one process can run simultaneously. Okay, so in multiprogramming, CPU can execute process 1 and process 2 and vice versa. Means sometime process 1 will be execute or sometime process 2 will execute till we continue. Means suppose process 1 is executed, then process 2 is waiting. If process 2 is executing, then process 1 is waiting. Okay, means in multiprogramming, one thing is remember, in multiprogramming more than one process can run simultaneously. Now degree of multiprogramming. Degree of multiprogramming means, see here, this is also asked for 1 mark. Degree of multiprogramming. Okay, now in this the number of process running simultaneously and competing for the CPU is called degree of multiprogramming. Degree of multiprogramming means number of process. In very much simple word, when we having multi-programs at a time, just count the number of programs and that will be the degree of program. Means see here in this diagram, process 1, process 2, process 1, process 2. Okay, means here two processes are run. So here degree of multiprogramming is, means suppose degree of multiprogramming is 2. Degree of multiprogramming is 2. Okay student, this is called as degree of multiprogramming. Now next is context switching. Context switching, it is very important topic in this process management. Now context switching means in multiprogramming system, multiple processes are run at the same time, such when process 1 wait for input output operation and process 2 executes, and vice versa. Means maybe process 2 is required waiting for input output operation and process 1 is execute. It is called as vice versa. Means in multiprogramming, multiple processes are run at the same time. Now see in diagrammatically, see here, run process 1, process 2, process 1, process 2, process 1, process 2. Okay, now see here in this diagram, student, see this is a ideal. What is this ideal? Ideal means if process 1 or process 2 is completely executed, means just remember ideal meaning CPU in ideal state means cannot execute any process. Cannot execute any process means stop the process. Just relax. Okay, there is no any process for execution. Means stop the execution. It is called as ideal. Now then what is this? This arrow and this arrow means this is called as context switching. This is called as context switching. Means context switching means in this multiprogramming, context switching is more than CPU utilization. CPU utilization means CPU switch process 1 to another process, then time will be lost, and that time is called as context switching. Means lost your time. Which time? Process 1 to process 2. This time is called as context switching. Understood student? What do you mean by context switching? Okay, the loss of time in turning the attention of CPU from one process to another is called as context switching. Now next topic is, now first see the example, actual how to work context switching in program execution time or run time. Okay, this is a simple program. In this program, two processes are there. In this program, two processes means here process A and here process B. Where process A means this process A is depending upon process B. When process A is being executed, this process is executed, CPU executes instruction one by one. When it comes to the instruction, which instructions? This instruction. When CPU means pointer come to this instruction, cout add A, B, is stop the execution because the output of this instruction depends on output of process B. Now process B is here. Okay, means thus there is a need of execution of process B. So CPU store the content of register and flags of process A in register save area. Now student, first execute this part. First execute this process A. After coming to this line, then CPU jump to another process means process B. Then what about these flags or variables? Where it is stored the data? Is stored the data in register save area. Register save area. Okay. It then loads process B. After save the data in register, then this process B loaded into memory. This process be loaded into memory. The time required means, student, the time required for this is known as context switching. Okay, means when if pointer come to this line, after jump to the another process, means process B, this time required, this time is called as context switching. The CPU then executes process B, and output is given to process A, and execution of process A restarts from the instruction from which it was halted. Means after completed these B processes, then again go to main program, then complete your execution. It is called as context switching. Understood, student? How to work context switching? This is a simple example for context switching. Now next is process states in process management. Process states in process management. Now in board exam, this question asks for 3 marks. Explain process states. In order to manage switching between processes, the operating system defines 3 basic process data which are given below. Okay, which states running, ready and block. There are 3 states: running, ready and block. Now first let us see running state. Now what is the meaning of, or what is the function of running state? Now see, CPU can execute only one process at any given moment. CPU can execute only one process at any given moment. This process is termed as running process. This process is called as running process. Okay, means CPU only one program can run at a time. CPU only one program can run at a time. Then what about other program? Those program which is in execution process called running process. In multiprocessor system, see, in multiprocessor system with multiple CPUs, there are many running processes at a given moment. The operating system keeps track of all of them. Means if one process in execution step, then what about other process? The operating system keeps track of all of them. Means student, if more than one CPU, means multiple CPUs are available. More than one CPUs means multiple CPUs are available. So we are having the multiple processes can run at a time. Means at that time those maximum processes are running. Maximum processes are running. At that time operating system maintain the records of all processes. Okay student? If multiprocessor, not multiprogramming. Multiprogramming means more than one program can run simultaneously. Multiprocessor means more than one CPU. It is called as processors. Okay, means if more than one CPU, means multiple CPUs are available. Multiple CPUs are available. If multiple CPUs are available, then we are having the multiple processes at a time. Multiple processes at a time. At that time operating system maintain the records of all processes. Means simultaneously 10 processes are run, 10 different processes, then that all record keep operating system. This is called as running state. This is called as running state. Means running state means execute only one process at any given moment. This is known as running state. Understood student? Now next state is ready state. Next state is ready state. A process which do not waiting for any external event such as an input output operation and which is not running is said to be in ready state. See student, here a process which is not waiting for any external event. Any external event means input output operation. This is very important state. This state is very important because those processes which complete those processes which complete the input output operation, but it is not in a running state. Understood? Those processes which complete the input output operation, but it is not in running state. Also, it is called as a ready state. Means those processes which complete the completely working of input output operation, and it is waiting for that CPU time. It is waiting for that CPU time. So that process called in ready state. Understood, student? Now last state is block state. Last state is block state. In block state, when process is waiting for an external event such as IO operation, means input output operation, the process is said to be block state. See here, in previous state, not waiting for external event means input output operation, but in block state it is waiting for external events such as input output operation. Now see, in this state process is not completed. In this state process is not completed. Input output working means process not having any data. That process is called block. That process is called block. Understood? In ready state, not waiting for external, means here complete the input output operation, but in block state not completed the input output operation. If don't have any data, then which data are executed? So that process is in block state. Then what is the difference between in ready and block state? The major difference between block and ready process is that a block process cannot be directly scheduled even if CPU is free, whereas a ready process directly scheduled if the CPU is free. Why? Because ready state complete the input output operation, but in block state not complete the input output operation. So it is not directly scheduled. If CPU is free, then it is not entered into CPU, because in block state process not completed data, not completed input output operation, but in ready state it is completed. So it directly scheduled to the CPU when CPU is free. Understood, student? This 3 state asked for in board exam for 3 marks, and many times this question will be asked. Running state, ready state and block state. Understood, student? Now this is the end of session 5. Thank you.